Now we have to go on straight to our next panel, panel 5, which is digital twin, what the integration of AI means for speed and accuracy. For this one, we have moderator Philip Black, PE, for his Global Emerging Solutions Lead, Digital and Technology with Wood. Philip.
Thank you very much. Thanks for joining this session. We've got a great group of people ready to talk about digital twin and AI and the combination of the both. As Stuart mentioned, I'm Philip Black. I'm one of the Global Emerging Solution Leads of Wood with their Digital and Technology group, where I focus on helping clients across multiple industries on their digitization journeys. I'm responsible for looking at all the industries we serve in order to ensure that technology used in one industry doesn't get stuck, can get moved across, and benefit other industries as well. Today, we're going to focus on two specific buzzwords that capture a lot of potential, and if we can get beyond the hype and into useful projects that generate value, they have great promise. These topics are digital twin and artificial intelligence. The concept of digital twin has been around quite some time. NASA pioneered the concept of digital twin in the 60s in order to ensure they had the ability to troubleshoot problems and develop solutions for the astronauts while in orbit. Although expensive, the physical, twin, proved its value after the launch of Apollo 13 when the oxygen tanks exploded in the mission. Technical issues were resolved from 200,000 miles away in real time. Now, yesterday on the event chat, there was quite a lot of discussion on making sense of information within energy and how big tech companies have grown powerful, primarily due to their ability to digest and take action on giant amounts of data they've collected on everyone that uses their platform. The radical changes required to transition to a lower carbon future means that energy producers will have to better understand the information they have stored in multiple systems, in multiple forms, and generated by multiple groups. Many of these groups are highly technical and have very different vocabularies and ways of seeing the same physical asset. In energy production, there is more than just numerical sensor readings or server logs. There are free-form notes from operations and maintenance, photos of inspections, videos of operations, and drawings of how things are actually supposed to be, although we know that's usually not the case. Artificial intelligence promises the ability to provide context to the multiple types of information streams. Digital twins promise the ability to access large information sets and provide the right information to the right person at the right time and in a format that can be easily understood outside of the domain in which it was generated. Now, both sound good in marketing material, but what does it take for energy companies to actually realize the benefits that are promised? This is what we're going to focus on today. I'm going to give each of the panelists a few minutes to introduce themselves, their companies, and their perspectives on digital twins. Then we'll start a conversation. Please add your questions to the chat as we talk, and we'll be happy to address those during Q&A at the end. First, I'd like to start out with Mark Brownless. Mark, geologists have been dealing with giant data sets for a long time. What's your perspective on digital twin and AI?
Hello, hi. Thanks for the question. I'm Mark Brownless. As said, I'm not Philip Black. I'm a geologist. I'm carbonates and geochemistry and isotopes, all sorts of weird and wonderful things. So in the context of some of the conversations we've had over the last day or so, I like working with the hidden data types. So geochemical data, petrological data, but also with the thing more visible. So seismic data, well data, production data, the sort of standard things that people associate geologists with. I work for a company called Geoteric. I've been with them for a number of years. And what we are doing is applying AI, ML, deep learning, all variants of similar or related things, particularly to subsurface data. So essentially things you can't really measure. And the reason that we're doing that is we think that you can get a much, much better understanding of the Earth by looking at it with some of the modern analytical tools. I've been working with geological understanding and assets and technology for, sadly, it turns out it's 30 years, for which I'm very grateful. And I've seen a few things in my time. I was involved from the very early days with the development of a tool called Petrel, which is fairly well established in the E&P industry. It was bought by Schlumberger from Technoguide, crikey, a long time ago, back in the zeros, the noughties. So I've been really curious about digital twins for a very, very long time. What do I see a digital twin can do for us? Well, really, I think it can get us closer to the truth. What we can use with the tools that we have available today allows us to see things much, much more detailed. So we can see interpretations and information coming out of seismic data that we could never have possibly seen using traditional techniques. And I think that by doing this, we can actually bring the cycle times in closer alignment. So the cycle times of subsurface understanding and subsurface teams closer to the cycle times of drilling teams, for example, to be able to understand things and update drilling plans and locations before you start drilling them based on information from new things. So really, what we're seeing is a massive growth in the compute power, the AI technology, the machine learning, the deep learning. And I think that we can now get to insights at a much, much greater fidelity, at a level of detail that we just couldn't have done. For the more experienced among us, I guess what we're really talking about is higher fidelity interpretations and relationships, real detail on things like fault networks. Are things compartmentalized? Are they not? Basically getting the Earth to deliver up its secrets to us by using new techniques. And the time compression is really quite astonishing. So from my point of view, a digital twin should be something that has the closest that we can get to the truth. Somebody mentioned a single point of truth. That's great if you can go and measure it with a tape measure, but in the subsurface, it's a little more difficult to do that. So using digital twins are the way to go. Trying to use the best information will allow us to look at confidence. Using these tools to allow us to ask the what if questions. What if we do this operation? What if we do that operation? How do we enhance communication between disciplines? And how do we bring different data types together, which is a recurrent thing? So I'd like to see us really using digital twins with the new AI type tools towards a view of confidence. Instead of looking at uncertainty all the time, there is inherent uncertainty. If we can get an indication of how confident we should be about things, I think that would really help and change the way that we actually operate. So really, that's my view. I'll probably stop talking there.
Thanks. Next, we have a couple of operators on the panel. So I'd like Rolf and Ken to introduce themselves and get the operator's perspective on digital twin and AI.
Yeah, thank you, Philip, and thank you for the introduction. So I'm Rolf Sæter. I'm heading up the improvement, innovation, technology, and digital work in Norway for all part of our operations. And I can easily echo Mark's very well explanation. I will bring it into a broader context as well. I think for us, a digital twin is to think reservoir to market in the whole life cycle of an asset. But we also see when we move forward now that you also start to look into the broader infrastructure around our assets, the export pipeline, the influx of energy to produce So it's actually give us the opportunity with liberation of the data that actually define our operations from reservoir to market in the greater infrastructure to chase margins, to control the behavior, the dynamic behavior, and also to improve the way of working in the reliability, availability, production, energy consumption space to actually maximize the revenue out of our assets. So the liberating of data to connect the right technology together, so you have an absolutely truth replica of not only the physical world, but also the dynamical world. And then move from a more reactive static dimension to actually be capable to predict, to feed our intellectual capacity in the organization with views, insight, opportunities and threats, which we can adhere to actually control and achieve what we are after. So I think this landscape in a technology dimension has been talking about data liberation for some time now. I think the most important part of this journey, also when you integrate IE, machine learning, fidelity models, and so on in the twin, is actually to liberate the intellectual capacity in the organization and integrate that so we actually can achieve more with less. And this is a really inspiring journey for our professionals in our business, because we can give them in their fingertips a more precise definition of what is happening, a more precise suggestion of what could happening, and then we can pair that up with our intellectual capacity and achieve more. It's a rocket for innovation.
All right, Ken?
Yeah, hi. So my name is Nguyen. I am the digital program manager at BP. Currently, I'm leading the digital team at BP to implement technology, whether it's infrastructure application and modernization transformation for a major capital project in the Gulf of Mexico, a greenfield project called Mad Dog 2. So as I kind of ponder this question, there's a couple of things that's come to mind around the digital twin and around artificial intelligence. So 3 words that really come to my mind when I kind of think about this is that when we look at these 2 concepts that, as I think Phil mentioned earlier, it's been around for some time. So I think of these 3 things. There's 3 words that come. So it's one, it's overuse, right? We hear this used all the time and for many different ways, right? A digital twin could be as simple as a spreadsheet with real-time data to something much more complex than that. And because it's overused, and similarly with AI, it could be used from anywhere with a macro with some business logic, all the way to complex quantum computing, artificial intelligence. Because it's so overused, it's oftentimes misunderstood, right? So people, because you misunderstand where and how to use it and what it means to them. So then, because of these 2 things, then it's oftentimes underappreciated, right? Because it's so commonplace, it's thrown around and bantered around so often that those 3 words kind of come to my mind. So one of the things that, in my view, that we need to do as an industry really is to better define what that means, right? For one, a digital twin, in my view, there can only be one for any given asset or field, etc., that represents the entirety of that asset. So as an example, on this capital project that we were running, we built what we call the dynamic digital twin, which is a solution that unlocks business value by aggregating disparate complex data sources and transforming it into lifelike visualization. What does that mean? It takes it and gets all of, whether it's the facility to the subsea infrastructure to the reservoir, integrated in a way that makes sense. And the key thing I think that Rolf and Philip mentioned is the ability to contextualize the data. It's not enough to get the data. It's important now to be able to contextualize what that means to the person who's looking at that data in a meaningful way. So by us building this together, we've been able to take both static data that static model, tags, document, data sheet, etc., and integrate that with dynamic data, right? Whether it's production information, whether it's things like vessel location, things like ROV location, real activities that we blended together to create a real living, breathing digital asset. So I think that's the first step, is to ensure that we kind of operate in the same frame space. Now, when I think about artificial intelligence, there's been a lot of work that's gone on around the use of machine learning, and then of course machine vision, deep machine learning that goes out there and take some of these work and attempt to contextualize it. But in my view, that still is not, in my opinion, artificial intelligence, because it's still a human being developing the algorithm to do some of these things, right? So when we get into artificial intelligence, that's where we reach into the use of quantum computing to have cognitive artificial intelligence to look at. So one of the things I think, Philip, you mentioned earlier about work from NASA early on for digital twins. One of the things that we recently been talking to some of the academic institution that has to deal with some of these deep space probe, like Cassini and other, that how they maintain these assets as they're going out there that could take, it has to operate independently. And so we've been trying to get that learning to implement how we can take that to not only how we build facility, but to how to operate it. Of course, the ultimate goal at some point, or the aspiration, because we're looking to build these facilities that last potentially 30, 35 years, is, at least the aspiration is, at some point, can we get to the point where we can have a self-running, self-healing facility that can go and take overall business parameters, such as production rates, such as carbon emissions, such as turnaround, etc., and be able to make adjustment and dynamically and operate that as a pardon the pun, well-running oil machine. So when I look at that, there's a tremendous amount of potential in the use of digital twin for an operator such as BP, and the use of artificial intelligence to provide data that's more accurate, that's more faster, but more importantly, that is contextualized, that presents it in a way that people can actually take action or get recommendation from these artificial intelligence to then spend time doing the value-added work rather than just the number crunching. So I'll stop there.
Thank you. Finally, both Shane and then Rob will introduce themselves and give their perspective from a service and technology provider background. Shane?
Hi, thanks, Phil. So my name is Shane McArdle. I'm working for Kongsberg Digital, which is a global software company focused on digitalizing the world's heavy asset industries. So my team is responsible for CogniTwin, which is our dynamic digital twin. And basically, I'm not going to get into the nitty-gritty of how you define a digital twin, but basically what CogniTwin does is it provides a unified view of your IT, OT data. That's fundamental. And we also take a very much, it's built on the principle of being data-driven. So we embed analytics, and I'm very careful in the use of this AI term, as Ken mentioned. So it's built on advanced analytics and machine learning algorithms, and this is pasted into the fabric of the twin. And what that allows you to do is just to get a better representation of your asset. Now, there's three things I'm going to talk about what underpin, let's say, a digital twin as a vehicle for AI, advanced analytics, machine learning, and that's really contextualized data. And Ken hit the nail on the head. It's not really about having more data. There's a lot of data out there, and all of this data is stored somewhere. It's just that it's in multiple data sources, and that's a challenge, right? You need a tool that unifies these data sources. So our CogniTwin has a contextualization engine and a data pipeline. All of this is, it's semi-automatic or fully automatic based on advanced algorithms. So we have a data pipeline highway. It pulls it into our contextualization engine. This then contextualizes multiple sources of data, and it can be, photogrammetry, ROV data. We can take flat, 2D documents like PNIDs. We have tools to scrape PDF versions, OCR technology, metadata from 3D models, simulators that provide more synthetic data like flow assurance tools to represent your subsea infrastructure, but also your topside process simulators. So all of this data is piped in, contextualized within our contextualization engine. It's combined, it's structured, and it provides a more consistent, accurate, and basically useful set of data. All of this data then is just made available through an open API. So everything is open. You don't want to build silos inside your twin. That's really, really important. You don't want to just build another silo to host all your data. It should be open. So open standards, open APIs, plug into your existing infrastructure. We don't want to become like another system of records. There's already places to store that. But the challenge is unifying this data and contextualizing this data. And it has to be done fast, and I'll come back to that in a minute. The AI part, and we have to be careful with this term. Like there's very few companies in the world actually doing true AI development, right? And you're thinking of MindSphere or Google. They're really advanced in their AI technology. But there's a lot of value to be gained from machine learning and from advanced analytics. Really, there is. And what you need to be able to do is you need to be able to operationalize this. You need to be able to get this into your frontline workforce. So we look at the oil and gas and we see a safety critical process industry, right? AI, if you think of it, is a black box, right? So you pump in your data and your model prescribes some information or gives you a prediction. That's not very safe, considering the inaccuracies that can be built into these models. So we talk a lot about a hybrid machine learning approach or hybrid AI approach. And Kongsberg has quite a few, let's call them high fidelity physical simulators. And we blend pure data analytics with our physical models. So we have applications we try to apply like our data-driven models that are enhanced, but also constrained by the knowledge of the physical world through our simulators. And that's fundamentally important. So if you want to make sure you have something explainable, something you can trust, something you can scale, we believe the hybrid machine learning approach is the way to go. So while we have analytics and machine learning built into our contextualization part and the data-driven part, the applications such as hybrid AI, hybrid machine learning, that also is a very, very important part to getting, let's call it, operational capability into your frontline workforce. So you're able to quickly deploy these advanced tools, advanced systems into your frontline workforce in a simple way, because all of it is all about being simple. You have to think about it from your user perspective. If you want to get people to adopt this, it can't be complicated. You can't add complexity into an already complex world. So you want to make sure that whatever you're deploying, does this make this person's job easier? Yes, no, yes, that's great. It simplifies what their mundane task or simplifies a complex decision-making process. It's very important that you link your digital twin, your AI and machine learning to a business process. Finally, it's about pace. It's about speed. A lot of people get bogged down into, we have to set up a large team to handle this. We need to surveil the market. We need to understand what types of data we have. Is this going to be a data lake? And you have to drop the barriers to this pace. So we've taken a very modular and, as I said, data-driven approach. And from a service provider, we see this being advantageous to those operators that just want to quickly innovate or quickly test. Is this feasible? And we're not talking months, we're talking weeks here. Can we grab, your engineering data warehouse information? Can you contextualize that with your 3D model, your RV video stream, your simulator data? Can we scale out some of our existing data models? So we can do that extremely quickly. And then you get it into the end user's hands, and this is where the magic happens. I mean, this is where people give you the honest feedback in oh, this is terrible, or you start seeing some of the resistance, or you hear comments like, this is going to change my life, the ways of working is fundamentally shifted, and that's how you quickly innovate. So speed is important. Drop the barrier to the pace. Hybrid machine learning and contextualize the data that you see as valuable. You don't have to contextualize all data, just contextualize the data that you actually can get value out of. So from a service provider, they're my thoughts around the topic.
Thank you. Rob?
Yeah, thanks, Philip. So just quickly to introduce myself. So my name is Rob Kennedy, and I lead Wood's digital twin program globally. So Wood really is focused on delivering consulting projects and operations to clients in the energy and the built environment. And I guess digital twin is really a key service for our business going forward. And we're working with some of our key clients and technology partners to, I guess, integrate the right technology solution for our client's asset that can really drive value right through every stage of the asset lifecycle. And just quickly, I wanted to kind of touch on our full asset lifecycle approach, because I think this is really important. So, for a given asset, maybe somewhere around 20% of the total expenditure will happen during the capital phase, and the remaining 80% will happen during the operations phase. Historically, we've seen, the sort of the starts of digital twin has really happened during that design and build phase, but oftentimes it doesn't translate across into the operations phase. And I think that's a really significant lost opportunity, and there's huge value to be gained during that operations phase around optimizing, the operations and maintenance and driving value. So specifically onto the role of AI within digital twin, and I think Ken and Shane really have set the ground really nicely for me, because the discussion here around what is it really we're calling AI, I think that's a key point, and also this real emphasis we're putting on data contextualization. I guess I wanted to maybe give sort of three key examples of where I see AI or machine learning or hybrid AI. We can maybe split hairs around the terms we use, but where these models are really already driving value when integrated with digital twins. So the first example I had really, and this is back to the whole concept of contextualizing data, and contextualizing the data we have around an asset is great and all well and good if we actually have data about that asset in the first place. And a lot of assets that we work on exist in the physical space, maybe with physical documents and drawings, no 3D models, and to actually be able to generate a digital twin, even just a fairly rudimentary 3D representation of our asset, there's a huge activity to go and digitally capture and digitize that asset. Now, when we have a 3D model, we can use these machine learning contextualization pipelines to link our 3D model. We can scrape tags and information from documents and drawings, and we can contextualize the data. However, if we don't have a 3D model, and if we maybe don't even have a tag hierarchy for that facility, it becomes extremely challenging. And a lot of our technology partners are investing considerable amount of money in being able to take a 3D, like point cloud or photogrammetry model of our asset, and then apply intelligence and predominantly machine learning models to identify different types of assets. So to be able to tell the difference between, say, a valve and a flange as an example, but then actually to be able to identify which valve or which flange exists in that particular area of the model. So that's one really valuable area, and particularly as we try and extend the lifetime of existing assets and optimize them through using digital twin, the ability to rapidly create that digital replica of an older physical asset is super important. The second area, and this is really, I guess, under the umbrella of aiding decision making and helping specialists. So this could be maybe an AI agent that runs and maybe will detect the degradation of a piece of equipment and can maybe detect that degradation far in advance of when a specialist would maybe be able to identify it. And here I think the key is, someone before mentioned explainable AI. And we're definitely not at a point here of being able to trust the AI to completely make all the decisions for us. The focus, I think, is helping our specialists with some of the heavy lifting, allowing some of our machine learning models to flag issues to the specialist for review and investigation, but then trusting the AI to sort of deal with and be able to flag up some of the less critical issues. So in that way, our specialists are able to really maximize their focus on the high value areas and the most critical issues that they have. And then finally, the other area, which I think is just about at the point of being sort of through its development phase and it's starting to be deployed in the real world, is there's the whole area of visual inspection of assets, which is, I guess, a key part of determining their condition and their integrity. That whole visual inspection process, be it if it's on a topside facility or an onshore facility, is labor intensive. When you put it subsea, is not only labor intensive, but extremely cost and time intensive as well. And it's also all down to human interpretation. So therefore is subject to human error and maybe a level of inconsistency in terms of identifying an anomaly initially and then classifying that anomaly. So we're using augmented machine vision models to automate both the detection of equipment features and anomalies, and then classifying those anomalies to reduce the amount of human input required, I guess, from our specialists, but also maximize the speed and the quality of the inspection. So just, I thought three sort of real life examples of how we're already using AI or machine learning models within the context of digital twin that are already adding value.
Great. So first, I'd like to talk about and get the perspective from both Ken and Rolf in terms of what are the barriers you see preventing the value of digital twin and AI from being realized by operators. Can we realize the value? Do we need to do it separately, look for each specific technology one at a time?
Yeah, so I think some of the challenges that we've seen is I would define kind of in two ways. The first is around the mindset, right? So it's around getting people used to trusting the data. The problem has been in the past that people get the data and it's either outdated or it's incorrect, and so they don't trust the data. So they end up not believing in the process. So the first part that we're trying to do is kind of change the mindset, change the way people think, how they approach things. Is around I think a few people have mentioned speed and the agility of delivering a solution in a iterative way. Long is the day gone where you go waterfall, deliver a solution 6, 9, 12 months later. It's got to be something that is succinct, that can add value immediately. That in turn build on becomes a snowball effect, so that people see the value, they begin to add it, they begin to help you innovate, and that changes their mind. And then the last part of it is that the actual digital solution, in this case, in some cases.
Okay, hi everybody. As you would have noticed, we had slight loss of signal there, but sorry about that. But the good news is the panel is still there, and I believe the signal is working again. So back to the panel.
All right.
Sorry, we're back. So okay.
All right.
So
Sorry about that.
yeah, that's just what I was saying. So the last part is the technology. It's got to be to the point where you be able to deliver. That's why agile, the ability to be agile is very important. The technology changes so fast. So I'll leave that. Those are some of the challenges that we have. But I think because of the environment that we're in today, whether it's cost challenges, or other challenges, political, climate, whatever, it's spearheading the evolution of transformation in a pace that we've never seen before. So in that perspective, I think it's that could be the silver lining of where we're at today.
Okay. Rolf, what do you think some of the barriers are? Uh-oh. All right. Well, let's talk about some of the opportunities that these technologies can bring, and how they will break down the specific barriers that Ken mentioned, both digital twin and AI. Mark, what do you think from a subsurface perspective?
Thanks for the comments. It's been really interesting listening to you all. I think one of the things that keeps recurring back on the, particularly on the AI piece, is the confidence thing. One of the ways that we got our guys into working with this was to be honest, initially they were very, very skeptical. They didn't want to go anywhere near it, really. But over the time period that they've been working with it, over a couple of years, they've seen that actually AI, because of the way it looks at data and information in completely different ways to the human mind, if you can train it in the right sort of a way, it can show you things that you simply can't see as a human being. And one of the things that we're working very much on this journey with is very quickly. So we're trying to, a phrase that keeps cropping up is hybrid workflows. We very much believe in integrating the end user into the workflow process. So we are trying to take the technology as close to the traditional familiar workflow as possible to allow people the confidence to get going with these AI technologies as quickly as possible. And our experience really is that if you start with a problem and you're able to allow people to see that it is doing something very, very useful for them, their mindset will change and they will start to adapt to this, adopt this technology. And that actually requires quite a bit of UX, user experience design, bringing people in line with the technology. And it's requiring us to think quite hard about how to do it. What we're seeing is that just really rapid results and ease of use kind of drops that entry barrier for people quite dramatically. And one of the things that I would say, just listening to what people have been sort of saying today, is trying to solve everything in one big hit. So trying to solve from the reservoir, which is my part of the world, all the way through to, I don't know, delivery at the forecourt, for example. There's clearly a hydrocarbon chain all the way through there. But trying to solve that huge problem as the first hit is probably a big ask. If we can pick off a few strategic pieces and provide answers to those and provide confidence that the AI actually is doing something incredibly useful, I think we allow people to become confident in what we can actually do. And really, the speed and the sort of the fidelity that we mentioned about the detail that you can pull out using true AI basically allows people to be freed up from their traditional jobs to be able to think. And I think that really what a lot of this technology was, let's just take the term artificial intelligence. Yes, it is the use of computers, but I think that the best way to do this is to use the computers to free the humans to use their creativity and thought process to actually deliver much, much better projects overall, because humans are fantastic integrators. And that's really where our strengths lie at the moment. I think I'll stop there.
All right. Rob, any final comments on opportunities?
Yeah, so I guess I just wanted to maybe touch quickly on an area that we've been going through recently on some projects, which is just around data quality. And this applies both to AI and to digital twin. It's the old garbage in, garbage out. And really, we cannot underestimate how difficult it is to achieve our nirvana of this perfect digital twin, particularly on an existing asset. This is maybe a little different on a new build, but on an existing asset, the differences in terms of the level of quality between assets within the same region, maybe of a slightly different age, is considerable. So our ability to truly transform workflows is so reliant on having a consistent, reliable, and I guess assurable level of data quality. Without that, we find, one, users don't trust the tool, but two, if we sit a user down in front of the shiniest, most brilliant digital twin that the industry can offer right now, and if they can't find a piece of information that they're looking for, be it pulling up a maintenance work order or finding a recent photograph of a particular piece of information, they immediately will decide that the digital twin is maybe a distraction. It doesn't help them to do their job. And unless we can demonstrate to those users that it helps them to do their job, they will never adopt the tool. And I have a bit of a mantra that the difference between a shiny tool and creating value is in the hands of the user. We have to make sure that we're doing everything in our power to engage those users and make their journey, I guess, in digitizing or digitalizing their workflows as seamless as possible.
Great. Shane, we have a couple of minutes left. Any parting comments from you on opportunities?
Sure, Shane, I suppose you meant there, Phil. Yeah. No, just listening into some of the challenges and some of the experience as well from Robert. You need to focus on the minimum amount of functionality that brings clear value, right? And that's the agile approach. You can't think big here. You have to eat the elephant with small bites. But you need technology that is built or already developed to get you to a point where you can start looking at these business functions that you want to digitalize. So we have a cloud, first, web first approach. So there's a lot of services you can leverage from your cloud environment. It allows you to be more agile. You think more in a DevOps with a DevOps methodology. We have all of the infrastructure to basically the data pipelines, the contextualization, but that's only the start. Really, it's only the start. It's at that point that you have to engage with your end user and really understand what are you trying to solve here. So that's linking it to the business value. Always have that in mind. But have that in mind with that's the end goal. But how do we get there? So we collaborate very closely with the customers. And we run these sprint cycles. So once your data is up, it's unified, it's made available, you've identified all those, let's say, tagged to document assets, problems or errors in your data, we've cleansed it, we've fixed it. Then that's where the innovation starts. And that's very close with the customer, very close with the end user. Mark mentioned about having a user experience focus, so, design focus. Really pushing out new features and functionality every 2 weeks. So it's all about, okay, we discussed, we iterate, we push out the feature, the functionality, we put it into the user's hands, and we iterate based on the feedback. So that's the way we work. It's very fast. Robert also mentioned, Nirvana, the utopia is obviously your greenfield asset that's been born digital. All your data is structured, everything is set up in particular hierarchies. It's all open APIs. It's fantastic. That isn't the majority of the assets that we work with. Your average asset is a medium-sized brownfield facility with some updates. Maybe they have put in maybe a historian. That's probably one case that they've focused on. Maybe an EDW, an engineering data warehouse, but all the rest of the data is just siloed. So how do you unify that data? That's traditionally what we deal with, and that is where you need the building blocks to bring you to a certain point where you can be innovative and in an agile manner and fast. So that has to be fundamental to your twin.
Thank you very much.
Okay, and I think we are nearly out of time, and recovering well from that little glitch we had earlier on. I have actually got a question that has come in, which I'd like to quickly ask you. Literally, we've only got 1 or 2 minutes. So, Philip, I'll leave it to you how you want to distribute this to the panel. But, if I just sort of summarize some of the very interesting things you've been talking about here. So, in the end, very few companies are actually doing AI properly. You've got to be at the Google level to really take advantage of everything. That's just a reminder for everybody, isn't it, listening in, that that who's really doing this properly? Not many. And to be able to operationalize this, God, there's another word, and contextualize this. And this is a complicated subject. Anyway, but you've got to get right in front of workforce, and then you have to get very fast feedback when they are running with it and make the improvements very fast. So it seems to be right at that interface where then the data has to be good, the listening has to be brilliant and transparent, and then the self-improvement or the improvement process has to be brilliant. So I guess looking back to then how Google does it, and then applying that now to this process of that interface and optimizing it so that companies can really, when they do apply AI and digital twin, have the most successful outcome. What can we learn from how Google did it, or continues to do it, as we now try and optimize and learn how to do this process properly in oil and gas? Just that interface, how do we get that right?
Yes, I'd like to hear Ken's perspective, especially since they're working with outside of the oil and gas domain. You mentioned NASA. In terms of what other areas, what other technology are you partnering with other companies to get this, ramp up this knowledge?
Yeah, so I'll just touch base. I know we don't have a lot of time. So one of the things is that we reach out to a company, Google, Amazon, right, where they really change their industry on the way they use technology to radicalize and move forward. So as such, we've talked to the space industry about sort of the same issues that they've had, right? They have to manage an asset that they can't reach, right? But they yet still have to operate. So what I would say, in order to get this implemented properly, in my view, is that you need to define what your end goal is, at least 10 years out or so. And you say, this is where we want to get to. And even though the technology, I don't believe, in terms of what I consider cognitive artificial, is not there, you sort of lay down, if that's the plan where you want to get to, right, where a system can learn how to learn, that can operate on its own, essentially. Then you work backwards and you identify, all right, where are we at today with machine learning, machine vision, deep machine learning, and you build these things up in incremental steps. Because it's very key to not let your user community get discouraged because they say, oh, that's way out, that's pie in the sky, we'll never get there. It's the little incremental things, but they need to see what the end vision would look like. And I think by doing that, it allows you to progress in a methodical way that hopefully, again, it's an aspiration. Will we ever get there? I'm not sure, but at least there's a plan in place that people can rally around. So I would leave it at that.
All right. Anyone else want to talk about?
Sorry. We I'm afraid are out of time, but that was very helpful. You've got to have a longer term goal. And then small steps towards it keeps the motivation going. So well done, everybody.